Hello everyone and welcome back to my implementation of Five Nights at Freddy's in the Unity engine. Today, in this video, what we're going to do is take a look at implementing the, whoops, it's not the right thing, brush. We're going to implement the win condition, which we had talked about in the previous video, but never got a chance to because we got so bogged down with setting up all the different nodes. But this one's really simple. All we're going to do is make sure that our current time is going to be greater than or equal to the duration of an actual level, which at the moment is set to 5 minutes. Now, this is simple enough. This is just going to be an if check to make this video actually worth it. What we're also going to add is the Five Nights at Freddy's rollover clock. So if we click on this video, we'll see that we have AM, and then it slowly goes up, gets cut off, and then the 6 pops up, and then we have some kids cheering. Now, I can't record the audio of cheers while I'm recording this audio, so I'll have to do that at another time and then insert it back in. But basically, the way we're going to do this is, we could do this a few different ways. I mean, we could just go into Maya, create some planes, create a texture that says AM over here, have the texture say 5 and then 6, and then have the UVs actually move so that the 6 rolls up and the 5 moves off screen. This is very easy to do in Maya, but let's do it a little bit differently. What we're going to do is inside of Unity, we're actually going to create the entire mesh. So it's probably going to be 2 separate meshes. Each of them are going to be using the same texture object, that is, and the texture object we'll make in here in just a second. And the texture object's just going to hold AM, and it's just going to have a 5 and a 6 above it. And then we're going to translate the UVs of this object over time, probably using a coroutine. So let's get started with the actual texture. So let me move my equipment. All right, so here we are with a nice big 2048 by 2048 texture. If we take a look at the reference material again, it's all black background, so let's go ahead and do that. Although, actually, we're probably going to want to make the background whatever color we decide to use as a background, meaning we're going to want to be using transparency. So let's go ahead and get rid of the background layer for this, File, Save As, and quickly save this file out as well. Let's go to Reproduce It, FNAF, Photoshop, and then let's call this 6 AM Rollover. Or just win clock, or win time. That's good. Enter. All right, so we're going to get rid of this layer, trash it. Not yet. I want to get rid of this layer. Got to have at least one layer. And let's create it. It looks like it's just some standard pixelated text there. So let's go over here and try to find something that's going to work. Oh, well, actually, that's darn close to it, but it's a little uglier than what we have in this video. Not quite as clear. Oh, that actually looks pretty good. FF Harmony Regular. Let's go with that, actually. So another way we could have done this was shrink this thing, make the text, shrink it down, go to image size, shrink it down, make sure we're going to probably do, it doesn't matter what we do, and actually it does matter. We're probably going to do nearest neighbor so we get hard edges, and then we're going to resize the thing back up, in which case we're going to choose nearest neighbor again, and in doing so, we should preserve the pixelation without Photoshop interpolating different values between the pixels. You know, that is blurring it to make it look better. Okay, so we'll just go with this. That was easy. This texture, this is probably still too small, but hold on. Now we need to think about how we're going to deal with the UVs. So on one side, to make my life easy, I'd like the UVs to be over here. So we're going to cut the thing down the center so we can use a guide if we want to. Not that it really matters in this case. And then on the other side, we're going to have the 5 and 6 AM. So I want these letters to, I guess, kind of fit within one of these blocks here. That would probably be perfect. And I'm going to want to separate this from the AM as well. But we are going to duplicate this, so let's go ahead and do that. And now that we have 2 of these things, let's do 6, enter 5. Actually, we want to do that the other way, don't we? Because it comes from bottom to top, right? Yeah, so 5 above 6. So let's do 5 and 6. Move this over here. And I guess we can have, let's see. If that's there, so what I would like to do is make this really simple for when I'm doing my UV calcs. And I want the size of these things to match up right. So let's just, or I could just wing it. We could do it that way. That works. So in this case, we've kind of centered this text. Then the 5 and the 6 are over here, wrapping on this. Let's make my life easier. Let's make sure the top of this text is at the 0.5 range, or 0.25 range, and the top of this one is also at that. And that's going to make things a little bit easier for me as things go on. We'll be having a plane that's going to start over here. Then it's going to move down, or the UVs will move down. We'll have another plane over here. The planes are going to be twice as wide as they are tall in this case. So let's go ahead and do this. Let's save this first. Save, file, save as PNG. How much of a gap was there actually? There's a significant gap between the 5 and the 6. So let's replicate that as well. Now there's kind of a gap, but probably not good enough. I'm thinking I'm going to separate the 6 now. Control X, duplicate the 5, move the 5 down to, let's say, there, and give that a 6. And with the amount that I move that, it should be like 0.5 units, I think, that I'm going to have to shift all the UVs. So that's good to remember. Save, file, save as PNG. Put this under my textures folder right now. Save, okay. And this text should be white, shouldn't it? Let's just grab it all, put it in a group, and then do a color overlay and make that almost white. There we are. File, save as PNG, reproduce it. No, sorry. Save, file, save as PNG, FNAF, textures, save, yes. Okay. All right, there we are. So let's go over here now, and under textures, let's just bring that in, import a new asset. Wrong game, that's my game. Let's see, YouTube. Reproduce it, FNAF, and textures, and win conditions. Now we're going to need the material, so let's create a new material. And let's call this win time as well. This texture should get its alpha from the transparency. Anisotropic level doesn't need to matter because it should always be most likely flattened to it should be tracked by the camera. It's going to become a child of the camera and will always be stuck to your screen most likely. Now this is going to need this texture for the albedo. This is going to be a cutoff. See what that looks like down there, and let's see if the cutoff will actually. Cutoff doesn't do a whole lot, so we'll stick it to 0.5. That's fine. Okay, so now we need to create the script that's going to handle this whole thing. And now that I am starting to make files, I am going to want to organize my hierarchy a bit. So let's make this win time. And go under script, go under here, right click, create a new C# script, and say win time. Let's just call it that. Textures, grab both of these now, grab them, put them under win time. And under win time now, in our script, we're going to generate our asset, our model through code. All right, so here we are in Unity. There's win time. Should we run this in the editor so we can actually see the outcome of it? Execute in edit mode. We'll do that. During start, I guess we can do start or we can do something else. We're going to need to require a few components for this one. So let's do required component type of, and then we're going to do a mesh renderer. And we also are going to do a... Actually, can I do multiple required components in the same line? I actually don't know if I can. Let's see if I can. Let's do type of mesh filter. All right, no problem. Just one at a time then. So 2 required components, and the idea behind this is just that it's whenever we attach this to an object, that object is automatically going to get these components attached to it, so we don't have to worry about any of that stuff. Save. You need another. Maybe I could have done it. Looks like the error I got was because I was lazy, not because of I couldn't do it. Let's try that again, actually. I'm very interested. X, V, save. Ooh, okay. Save this. Let's go back over here and create this now. Game object, create empty. Call this win time and put this on here. And good. Okay. So that means one less line we have to write in the future. So it went ahead and attached that mesh render and the mesh filter, but there is no filter at the moment, obviously. Let's reset the coordinates on this object. There we are, frame on up. There it is down there on the ground. Come back in here, and in start, or awake, and we can probably do it in awake. Let's do void awake. We're going to create this mesh. What we're going to want to do is grab references to both of the mesh render and mesh filter, because we're going to be working with them. So let's do mesh renderer, mesh renderer, and let's do mesh filter. And I'm probably going to get something that says I'm overriding something, but it doesn't matter. So inside of awake, what we're going to want to do is grab our references is equal to get component mesh renderer. Now, because we included those required components, I really don't need to do any sort of check and balance to make sure we actually found those and that the object isn't null, because those should, in theory, require the component to be attached and make sure it's there. Unless, of course, we change these and then don't reattach the script, because this only happens when you attach the script to an object. If you make changes to the script, like removing one of these, it's not going to go back and modify Unity. At least that's how it worked before. Okay, so we've got both these objects. Now we need to create the meshes themselves. We're just going to continue to do this in a way because there's no real reason to break this off into another function at this time. We need to create some boxes. So what we're going to need to do is create some arrays. We got to hold the vertices. We got to hold the normals. There'll only be one normal, but we need a mesh. So let's create a mesh first. So mesh is equal to new mesh. Now mesh is going to end up holding our verts. So we're going to need a vector 3 array of there we are, vertices is equal to a new vector 3 the size of this. So let's think about this for a second. Let's go over to Photoshop again and come back here. So we're going to have one, Control D. Let's see, in Unity, I can specify things other than triangles if I want to, like triangle strips and so forth, but we're just going to do a triangle. So we're going to do, we're going to start in the lower right here, and Unity is, DirectX, so it's a left-handed coordinate system if I remember correctly. So I want to go, I think clockwise is the way we want to go, like this, because OpenGL is counterclockwise. But anyway, the way we're going to do this is going to be vertex 0, 1, 2, and then this one up here is, no, we don't want to do it that way. That's 0, 1, 2, and then this will be vertex 3, and then the indices we're going to be giving this thing are going to be 0, 1, 3 for the first triangle 1, and then for triangle 2 it's going to be 1, 2, and then 3. And that should be going counterclockwise as well. We could use a triangle strip for this if we want to, instead of doing it by triangles, in which we would specify 0, 1, 3, and then 2. We'll deal with the UVs in just a second. So coming back over here, that means we're going to have 4 vertices, 1, 2, 3, 4, and let's create them really quick now. The size of these, well, we'll modify that to the scale of the element. Let's just keep this simple and easy. If we take a look back here, we do need to realize that the size of these are twice as wide as they are tall. So if this is 1 unit, this is 2 units across. That's pretty huge, 1 by 2. Now let's just keep it. It keeps the math easy, right? So let's do 0, 0 for the first one. So we'll do vertices. 0 is going to be equal to a new vector 3. We're going to do this a few times because we've got to fill in all 4 of those vertices. 2, 3, 4, and there we are, there we are, there we are. Each of these vertices, by the way, is going to need, if I remember correctly with Unity, you need to keep the vertices count, the vertex count, the UV count, and the normal count all the same based upon the number of vertices you have. You can't use different quantities of each. So here, vertices, this one is going to be 0, 0, 0, F, F, F. The next one is going to be 1 unit up. So that's going to be 0F, 1F, and this one is 0F as well. Now the one next to this is going to be 2 units over, so 2F, 1F tall, and 0F. But really, what do I want centered here? Do I want the corner of this thing centered in the world, or do I want the actual physical center of this piece? I'm thinking I'm going to want the actual physical center of this thing right about here, centered. Or actually, do I want this entire thing here to be centered? In which case, if I'm dealing with 0 here, this becomes 0, 1, 1, 2. So I should be making these -2 over in space. So let's take a look at this really quick. So if this is, what is this? A 1, 2, 3, 4 by 1 wide. So this is going to be like this. And I want my center to be there. And the whole thing's width is actually a 4. And this is a 1. The heights should be -0.5 to 0.5 in the positive direction, and then the width should be -2 to +2 going there. So let's correct that inside of our code. So over here, instead of it being 0, 0, 0, this should actually be a -2, and this should then be a -0.5. Then we're going to go up in the air, in which case it's going to be still at a -2 and a -0.5. Now, when doing it this way, I need to separate things. So this is going to be a block here, and this is going to be a block. So I'm actually going to have more than 4 verts. I'm going to have 1, 2, 3, 4, 5, 6, 7, 8. 8 vertices in total. So let's go ahead with that. I am reusing some verts, but that's because I want them to have separate UVs. If I shared these vertices, their UVs would also be shared, and I don't want that. Otherwise, these guys are going to get screwed up. I need them to be accessing different parts of this texture, and that's why it's going to be taking 8 instead of 6 verts. Okay, so here we go, -2, -0.5, -2, so we're going to do this a few more times, and I'm going to make this easy. We're going to separate these two. 2, 3, 4. There we are. And this is going to be 4, 5, 6, and 7. So this one's going to go from -2 to 0.5, -2, 0.5. This one's going to go now to 0 because it's halfway through that distance. To height is still 0.5, right? Oh, this height's wrong. This should be positive 0.5 because it's down, up, over, and then we're going to be coming back down again, in which case it's going to be 0F and then -0.5 F. And I need that 0, that Z value. F. Thank you. Okay, now this is going to be pretty much the same thing. It's going, well, it's going to be pushed over a few units, right? So it's going to be these values over here. So we're going to start in the lower portion of this thing, like we did before, and that's going to be this one right here. So it's this location. Then it's going to be this location next, because we're going up in the air. Now we're moving over, so we're no longer going to be at 0F, we're going to be at 2F, and then we're going to be at 0.5F in the sky, and then we're down at 0 right there. Put some Fs in there. And then the next one is going to be, we're still over in the X2 units, but we're down 0.5F, and we're over 0F. Okay, so those are our verts. Now we need our index list. The index list is constructed based on well, it's called the connect the dots game. It's an integer array, and let's call these indices. And that's going to be a new int of size. And the question is, what's our size? Well, that depends on how many of these we need to specify. So we need to specify 1, 2, 3, 1, 2, 3. It's going to be 3 for each triangle, and we're specifying 4 triangles in total, right? So there's this triangle, and then there's going to be this triangle, and then this triangle. So this is each 3. So 3, 6, 9, 12. So we're going to have 12 indices to specify all of these. So let's go ahead and do that next. So let's do, whoops, I didn't put that there. There we are. So now let's do indices, and we can do 0, 1, 2, 3, 4, and so forth. So on is going to be equal to something. Copy 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If you're really good, you can spend some time to do some math and create your own loop if you want to. And a lot of times you can do most of this stuff through loops, especially things like terrain generation and whatnot. It makes your life a heck of a lot easier. But for right now, since this is such a small object, we're just going to be doing it this way. We could have also made this so that since this is pretty much the same as this, but we're just shifting it over, we could have created both meshes, shifted one over by adding to these. Like literally, I could have taken these values here and then just added the offset value and stored it in there. And that would have worked as well. It's completely up to you on how you want to tackle the problem. Okay, so looking back at our chart here, what we want to do is remember that this is index 0, 1, 2, 3, and those are the indices we're putting in here. So the first place we're going to start off is 0, 1, and then 2, right? Because that's our first triangle. So triangle 1, triangle 2, there. We want to go in this direction for each, clockwise, 0, 1, 2. That's not how we did it. I'm sorry. It's 0, 1, 2, 3, and then it is 4, 5, 6, 7 is how we specified it. So it should be 0, 1, 3. So let's go back over here. So 0, 1, 3, and then the next one is going to be 1, 2, 3. And then for the next group, it's going to be 4, 5, 7, same pattern. And then the next one is going to be 5, 6, and 7. So technically, with this much, if we go ahead and set up our mesh, we can actually start seeing stuff on the screen. So let's do mesh.vertices is going to be equal to vertices, and then let's do mesh.indices, set indices, I'm sorry, is going to be the array we're using, which is indices. The mesh topology type, in this case, we're going to be just using triangles. And then our submesh, ignore this, it's just going to be 0. We're not using submeshes in this case. Okay, let's come back over here and find any error. Oh, big mistake I almost made. We need to set in the mesh filter the mesh. So let's do mesh filter dot mesh is equal to mesh. Simple, right? Okay, come back over here. Wait a second, see if any errors pop up. Rotate around really quick. And there we go. Something's happening. Good. And let's see. Grab wind time, move it up in the sky, frame up on it. And it's looking like we still have no mesh being generated over here. So what I'm going to do is actually remove this component, add component, and we're going to add wind time back. So there's a mesh. We double click it, we can actually see them being generated right there. So you can see, there it is. There's our different areas. If we spin around, because we have no material associated with it, we got nothing showing up right there. But it's very large, and obviously that's something we're just going to scale down right here. We'll mess with that. So this is probably going to be something more along the line. Actually, we'll just do that in the inspector. No reason to do it, or in the code. No reason to do that anywhere else. So there's our mesh. Let us make it easier for us to access things. So let's just do material, mesh material, or let's just call this material. No, we don't want to do that. Let's call this, well, actually, you know what? Because I'm doing this live in the editor, can I just take wind time, throw it on that? Okay, so you'll notice we've got nothing showing up now, and that's because we haven't decided to create our UVs yet. So let's create our UVs. So the UVs themselves, it's going to be a very similar process. There's going to be 8 UVs to go with our 8 vertices. So let's create a new list. UVs are, at least 2-dimensional UVs are going to be vector 2s. If you want to use 3-dimensional UVs because you're doing volume rendering or something interesting like that, then you'll use vector 3s. UV chords equals new vector 2 size 8. Perfect. Okay, UV chords, let's create them. It's going to be very similar to this, so I'm going to go ahead and take this part and do this and just change these to 2s. Yes, I know. And then this name here. Great. And then, of course, we need to get rid of those Z's. Okay, great. Now, thinking about our texture and how it was set up, coming back over here, this is the initial sample region, which is going to be from 0.2, I'm sorry, this is 0 and going up. Actually, I can draw on this, can't I? So let's create a new layer. So we're going to, this is 0, 0. I can't even see that, can you? 0, 0 is down here. This is going to be 1 over here in the U coordinate, and then the V coordinate is going to be 1 up going this way. Therefore, our range of where we should be looking at first is going to end up, I have snap on, don't I? Is going to be, the bottom is going to be 0.5, 0.5. Yeah, that snap is killing me. Turn that off. And then we're going to go from 0.5 in the X to 1.0 in the X, and then we're still going to be 0.5 in the height though right here. And then up here it's going to be 0.75 in the height, and it's still going to be 0.5 in the U direction or the X direction. And then over here it's going to be, 1.0 over, and it's going to be 0.75 high. This one over here is going to be a 0 in the X, and it's going to be 0.75 in the Y. This one down here is going to be equal to 0, and then 0.5, and then over here it's going to be 0.5. We already saw where those ones are. So let's go ahead and put these in. But remember, we want them to match what we have going on at first. So it's 0, 1, 2, 3, 4, 5, 6, and 7 is our current labeling. So 0, 0.5 is our first one. Let's move this over so we can see our chart to make things easier. So let's do it. 0.0, 0f, we want this to be positive 0.5. Then we're going to 2, which is also 0 in the y direction or the u direction, and it's going to be 0.75. Let's see. And then it's going to be 0.5 and 0.75, and then once again we are 0.5 over, but now we have come down to 0.5 right there. The other side is going to be similarly, it's going to be 0.5, 0.5. We're going to go up in the air after that. We're still at 0.5 in that direction, but we're at 7.5 right there. Over here, we're going to be now the full distance across in these last two. And we are going to be at 7.5, and then we drop down to 5, 0.5. Okay, so there's our UVs. Now, over here with our meshes, we're going to do mesh dot, UVs is going to be equal to UV chords. Right. That should be it. So once again, though, I'm going to have to nuke and restart this thing to make the work the way we're doing this inside the editor. So let's do remove, add, win time, and there we go. Perfect. Whew. So there's our time right there. Next up, we need it to rotate, right? We need this block over here to go up to 6, and yeah, let's do it. So we're probably going to do this with a coroutine, right? And what we're going to do is slowly add to the UV coordinates. So inside of that coroutine, we are going to be directly accessing our mesh, which will be stored in our mesh filter. Let's create a new function, enumerator change time. We'll just call it that. I don't believe we'll need to take any inputs for this one. Let's see. Probably want a function. I mean, we're going to want this to be void. Or no, we don't need to be void. Change time, yes, because you haven't returned anything. I understand. Okay, let's do a public void change time, or yeah, let's do change time. We'll change the name of that one. Okay, so this one is going to do a start coroutine, and the coroutine it's going to start is, of course, change time right there. Now, change time coroutine is going to modify the UVs on this object. Therefore, we're going to want to use our mesh. So we're going to do a mesh. Mesh is going to be equal to, what is it? Mesh filter dot mesh. Or we could do this that way. It doesn't matter. Then we're going to want to get our indices. So we're going to have our index list, which is going to be this right here. Indices is going to be equal to mesh dot. There we go. So now we're getting that list. Let's see. Oh, sorry, we don't want indices. Wrong thing. We want UV chords. Okay. And now we're going to want local variable name UV chords already exists because I put this in the wrong thing. That's why. Let's put it down here. Okay, so now is when we're going to want to start messing with time. We're going to want probably, let's make a public time change speed, or time, yeah, we'll call it that, time change speed. How long does this take in the game? So let's see. 2, 3, 4. Geez, like the actual time it takes is about 6 seconds. So let's do 6.0f. That needs to be a float. Okay, now coming in here, what we're going to want to do is continually move these a little bit by little until we hit that 6-minute mark. But the amount that we move is based upon a full transition. And a full transition is going to be, in this case, we're moving, what is it, 0.25 here. So we want, let's see, that 6 is really low. It's not, I should have put that somewhere else. Anyway, the distance in this entire thing is going to be equal to, how far does this thing have to move? Where's my, there we go, ruler. Let's try this. So we go from here roughly down to here. So height is 1285 pixels roughly. This is a 2048 image, right? So let's do our calculator. So let's do, what percentage of image are we moving? So 1285 divided by 2048 is, we're moving 0.62 units in this entire thing. So let's come back over here. Float distance to move is going to be equal to 0.62f. The amount we're going to move is going to be based upon the duration. So we need a speed of movement. So since we know how far we need to move and we know the time, if we divide one by the other, we can come up with our speed. So float text crawl speed is going to be equal to 0.62f divided by time change speed, right? Because now we have units in distance per time. And this is, of course, in texture coordinate units, and this is, of course, in seconds. So texels per second, and this should be here. And now we need our loop. That's going to continue to do this until we're done, until we've hit our magic number. So let's do a while loop. We could do while, what is our condition? While, let's do float offset total is equal to 0.0f. This will be an easy way to do it. So while offset title is less than the text, the distance to move, what we're going to do is continue to add to distance to move until we're there. So we need to update our UV coordinates, and we're going to do that to all these. So actually, this will be a for loop inside of that as well. And then we're going to want to set our UV coordinates as well. So we're going to want to do mesh is going to be equal to, mesh.uv is going to be equal to our new UV chords. Okay, so the loop itself is going to iterate over each of these and add to that vector the offset amount, which is only going to be in the y direction. And it's only going to do that actually for the first 4 UVs, 0 through 3, or 0 through 3. So int I is equal to 0, I is less than 4, I plus plus. So let's do UV chords I plus equals new vector 2, and this new vector 2 is going to be it's going to be 0.0 in the x direction. We only want to move it in the y, and the amount we're going to move it though is it's not our offset total, it's our delta offset, which we haven't made yet, which we'll make in just a second. So we'll need float delta offset is going to be equal to, well, whatever we calculate, which is going to be the time that has passed, the amount of time that has passed times our speed, which becomes the distance that we're working with. And then we're going to add that offset to the offset total. So offset total plus equals delta offset. Once again, I'm winging this, so as I do that, things are just kind of popping into my brain. So I'm trying to go with it as best I can. If it seems a little scattered, that's just how my brain works. Okay, so offset delta offset. So we need to calculate this by taking in the amount of time that has actually passed since the prior frame fired, and we need to times this by the speed that we're moving with. So text crawl speed. Okay, so that's going to move each one, shift it each the amount that it should be shifted, and then we're going to set it. And then what we're going to want is a yield return. No. So that's going to make it so that we come to the next frame. So this should continue to go until offset total is greater than distance to move. Now, if we get to that spot, it's very unlikely that this offset total is going to be exactly where we want it to be. So we're probably going to want to set it to be exactly where we'd want those UVs to be. So we're going to copy all of this stuff right here, and we're going to set each one's location equal to, we're just going to hard code it. So let's come up here, grab these, put them in here, and now we want everything shifted in the Y, what was that, half a unit, right? So actually, I'm thinking the UVs are moving down. I should be subtracting, not adding this, shouldn't I? So let's do that. And these units should now be down whatever that offset total is. And that still gets saved, no, distance to move, right? We want this to be the distance that it was at subtracted in the Y direction. So we'll actually let's just do it this way. And we save it one last time out to UV chords. And let's go ahead and make a way to fire this. So let's just create a public bool value, fire, or start win time is equal to false. And this is, we're doing it this way just to test right now. So let's do update, start win time, if start win time, let's call change time. And then we'll immediately set start win time equal to false. Run. We don't need to run. I don't need to run. Okay. Anyway, I don't need to do run. Okay. So instantiating mesh due to calling meshFilter.mesh during edit mode. This will leak meshes. Please use meshFilter.sharedMesh instead. Okay. Let's try this then. Or we can just stop trying to do this in edit mode for the moment. Let's do that. Let's come over here, clear this out. Let's nuke this. I got to remove these because it's done that inside the inspector. So now I've added this. Now we'll hit run. Come into the scene view. Oh, we don't have a... Okay, so we're going to have to make some changes to this already, aren't we? So put that there, and let's hit that. And then whatever we can see, it's rolling. Uh-oh. It's still rolling. Went too far. Went beyond the distance it was supposed to. And that is because my calculation was from the top of this to the bottom of that, as opposed to the top of that to the top of this. So if we do that, our height is now 760 roughly. So if we come in here now and make that change, and instead of distance to move, it was 760 roughly. So now we'll do clear 760 divided by 2048. 0.37. That's our distance to move. Save. Come back in here, hit run. Find the object, temporarily put the right texture on it. Let's hit it. Ding, 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 ding. Yay! And there we are. Now this video is getting really long, so before we start implementing the win conditions and making the game beatable, let's just cut things right there. Hope you enjoyed it. Hope you saw that it was really easy for us to do this all through code. In the next video, we'll fix this material problem and we'll hook it up so that you actually win inside the game, and we'll probably also parent this to the headset. Thanks, bye.